In this lecture, we're going to learn about the three-way comparison operator that was introduced in C++20. And this is an operator with one goal. Its goal is to let us know the result of a comparison and give us information if something is greater than the other, if something is less than the other, or if something is equal to the other in one go. I know some of you must be thinking this is crazy, but this is not a new idea in C++. If you remember, we have seen a compare method we have on the string class. We can use to compare two strings. For example, if we have two strings m1 and m2, one contains hello, the other contains world, we can compare them. We can say m1 compare to 2. So in this case, we are comparing M1 to M2, and this is going to do alphabetical comparison. And the one coming later in the alphabet is going to be greater than the other. But the result of this comparison is going to be stored in this integer, and we can do a pair of if statements. For example, we can say if result is greater than 0, we're going to know that M1 is greater than M2. If the result is 0, we're going to know that M1 is going to be equal to M2. If the result is less than 0, we're going to know that M1 is less than M2. We can do something like this. And if you hop over to the documentation for the compare method in the string class, you're going to see that this is the same behavior. So we have the information about our comparison stored in this result variable, which happens to be an integer in this case. And this is also the same logic we follow for the strcmp function in the CString library. And if the return value is negative, we're going to note that the first operand is greater than the other. This is what we are saying in here. If the return value is 0, the left operand and the right operand are going to be equal. This is what we are saying here. And if the return value is positive, we're going to note that the second operand is greater than the other. And this is what we are saying here. And the result of our comparison is going to be stored in the int that we return from this function here. So this is the same logic we use for our three-way comparison operator. And this is really funny. We have been talking about the three-way comparison all this time, and we haven't even looked at how it looks. And this is how it looks. It has a less than sign, it has an equal sign, and a greater than sign. And this really means that it's going to give you the information in one go. You're going to know if something is less than something else, if they are equal, or if one is greater than the other. This is the meaning of this operator here. But if you do something like comparing two things like we are doing here, the result of that is going to be a type that we have in C++20. And it is going to be storing information about this comparison. And one thing you should know is that the three-way comparison operator is not going to return a int like the string compare function we just looked at, or the strcmp function. It is going to return a type whose value is directly comparable to literal 0. So we can do something like this. We can compare the return value of a three-way comparison operator and compare that to 0. And this is going to give us the information if something is greater than the other, if something is greater or equal to the other, if something is equal to the other. We can really do all these comparisons and get our information. But note that you can't compare the result of a three-way comparison to and 0 value that is stored in an integer. If you try to do this, you're going to get a compiler error. So this is really meant to be compared to a literal value of 0 and not a value of 0 that is stored in a variable. You really need to know this. Okay, so some of you must be asking, okay, I know about the three-way comparison operator, but what is really its return type? You have said it's not an int. What is it? Well, it's going to be one of the three options we have here. It can either be strong ordering, it can be weak ordering, or it can be partial ordering. And I am going to explain these things in steps because they can really be confusing, especially for beginners. So let's talk about strong ordering. Strong ordering is a type that was introduced in C++20, and this type can be used to describe absolute equality in our comparisons. For example, for the fundamental type int, we can have absolute equality. If you say that 5 is equal to 5, you can't really distinguish between the 5 you have on the left and the 5 you have to the right. They are the same, and this is what we mean by absolute equality. And let's look at a simple example for strong ordering. Strong ordering is supported by default for integers in C++. So here we have two integers. One has a 45 inside, the other has a 56 inside. And we can compare them. We can say, is n3 greater than n4? We're going to get a result. We can say, is n3 equal to n4? And we're going to get a result. And we can say, is n3 less than n4? We're also going to get a result. But a special thing about this kind of comparison we do here is that we support absolute equality. For example, if in n3 we have a 45 and in n4 we have a 45, this is going to be true, the second statement here, and it is going to be saying that a 45 we have on the left is equal to a 45 we have to the right. Okay, so this is the meaning here. And you can't really distinguish between these two because they are absolutely equal. This is what we mean here. And let's look at what the official documentation has to say about this. STD strong ordering is coming in C++20 as part of the compare header. So if you want to use this, you will have to include this header. And it is a result of a three-way comparison. So you get a strong ordering type as a result of a three-way comparison. So if we go back at what we did before, for example, if we do a three-way comparison like this and compare n1 to n2, we may get a strong ordering type as a result of this comparison here. This is what we mean. Okay, so this strong ordering type can be used by the compiler to generate all the 6 comparison operators that we may need in our program. We can get an equal operator, we can get a not equal operator, we can get the less than versions, we can get the greater than versions here, and this is really cool. This is the whole point of this lecture here. But we don't have enough tools to really understand how these operators are going to be generated. All we really want to understand now is the difference between these things that we can return from a three-way comparison. Strong ordering, weak ordering, and partial ordering. This is the goal here. So strong ordering can be used by the compiler to give us all these operators. But the special thing about this kind of type is that it can be used to describe absolute equality. I have said that. And this is how the official documentation says this. This kind of type is going to imply that if A is equivalent to B, any function we can apply on A is going to also be equivalent to any function we apply to B. And what this really means is that A and B are indistinguishable. You can't distinguish them. If you say that A is equal to B, they are absolutely equal. You can't really differentiate between A and B. This is what we mean by absolute equality that strong ordering supports. Another feature of this type is that it does not allow incomparable values. We don't really understand this yet, but we will in a few slides ahead. Just know that it is possible to have a type and have incomparable values in that type. And when that's the case, if you compare A to B, you're going to get a false. If you compare A to B, using equal, you're going to get a false. And if you try to see if one is greater than the other, you're also going to get a false. So this is one way we have to say that things are incomparable. But with strong ordering, we only support things that are comparable. Now that we have an idea about strong ordering here, let's look at the possible values we can have in this type. We can have a less value inside, and this is going to mean that the left operand is less than what we have to the right operand. We can have a value that is equivalent, and this means that what we have to the left is equivalent to what we have to the right of the operand. And when I say to the right of the operand, I mean to the right of the three-way comparison operator. So if we have equal or equivalent, the two operands are going to be indistinguishable, as we saw on top here. And we also have a greater value, which means that what we have on the left is greater than what we have to the right. Okay, so this is all I really have to share about strong ordering. The main thing is that it supports absolute equality. We can also have weak ordering. And weak ordering is a type that can be used to describe non-absolute equality or equivalence. And here I have a simple example to drive this home. For example, we can say that two strings, hello and hello here, are equivalent because they convey the same message. They all say hello, but they are not equal because one is in full uppercase and the other is not. So we say that these two strings are equivalent, but they are not absolutely equal. This is what we mean here. And here we have a formal example. We have two std string objects. One is using all uppercase, the other is not, and we can compare them. So we can say that the first one, for example, is greater than the other. We are just using the greater than sign. We can compare them and try to see if they are equivalent, and we can compare them and try to see that if one is less than the other. But in all these comparisons, we support equivalence, not absolute equality. Let's look at what the official documentation has to say about this. Weak ordering is a class type, which is usually the result type of a three-way comparison. So we can get this if we compare things using the three-way comparison operator, and it is this operator that we just learned about in this lecture here. So this operator can also be used by the compiler to give us all the 6 operators here, but this operator supports equivalence. And by equivalence, we say that two things can be equivalent, but not completely equal or not absolutely equal, as we saw for the strings. This also only supports comparable values, so you can't use this to compare things that may not be comparable. And I know, again, this is really confusing, but I am going to make this clear in the next few slides when we learn about partial ordering. And these are the values we support for weak ordering. We have less, we have equivalent, we have greater. Less means that the left operand is less than the right operand. Equivalent means that they are equivalent but not necessarily equal. And greater means that the left operand is greater than the right operand. And when I mean left or right, I mean to the left or to the right of this three-way comparison operator here. We have another option of a type we can get as a result of a three-way comparison. We can also get an STD partial ordering type. This is a type that can be used to describe incomparable values in comparisons. And again, this is really confusing, but I am going to try and make this super clear. Here is a simple example that tries to compare two double types. One contains a valid value, which is 12.9, but the other contains a none. And this is a value we might have in a double type, which means that this is not a number. And if we go to c++.com, we're going to find a piece of documentation about the none or not a number. None values are used to identify undefined or non-representable values for a floating point type. And a good example of this is the square root of a negative number or the result of dividing 0 by 0. So if you take the square root of a negative number, you're going to get a none, which means that you can't really do that. We can't represent the result of that operation in any computer out there. So that's going to be none. If you also try to divide 0 by 0, you're going to get a none. But a special thing you need to know about this none is that you can't really compare it to other double values, because what do you expect to get from that kind of comparison? We can't do that. And we're going to try and use this fact to explain partial ordering here. So we're going to have a none in D2, and we're going to try and compare that to D1 using our greater than, equal, and less than operators here. If we do that and say is D1 greater than to D2, we're going to get a false. If we try and use the equal operator and say is D1 equal to D2, that's going to be a false because we can't really compare any double value to a non-value. This is the whole point here. If we try and compare using the less than operator, we're also going to get a false. So the main message here is that the double type may have values that are not comparable to other double values. And a good case for that is the non-value we have in here. And this is going to support partial ordering because our type here, which is double, supports values that cannot be compared to other double values as we do here. And in such a case, if we try to do any comparison, you are going to get all falses for the greater than, equal, and less than operator here. This is what I want you to know. Now, let's see what the official documentation has to say about this. Again, partial ordering is a type you get if you try to compare things using the three-way comparison operator. It can be used by the compiler to generate all the other operators. It also supports equivalence and not absolute equality, just like what we saw in weak ordering. And it supports incomparable values. This is what we mean here. And look at what we have here. Comparing with less than, comparing with equals, comparing with greater than may all be false. And this is what we just saw in this example here. This is a special feature of partial ordering. Okay, so hopefully by now you can see all these three types we return from three-way comparison operators have special meanings. If you return strong ordering, you are hinting to the fact that your comparisons are going to support absolute equality. If you use weak ordering, you're going to be hinting to the fact that your comparisons are going to support equivalence and not absolute equality. If you use partial ordering, you're going to be hinting to the fact that your comparisons may support values that may not be comparable to other values for your type. And this is really crucial to understand in three-way comparisons, as we're going to see in the next few lectures. Another thing I want you to know is that strong ordering can implicitly convert to weak ordering, and weak ordering can implicitly convert to partial ordering. So this may come in handy if, for example, you return a strong ordering in a function that is returning a weak ordering. This is going to be supported. But if you try to do things the other way around, you're going to get compiler errors. That's not going to be supported. Okay, so let's try to sum up what we just learned about in this lecture. So the three-way comparison operator is going to embody the result of a comparison in C++20. It's going to return a value whose value is comparable to literal 0. So the values in strong ordering, weak ordering, or partial ordering can be compared to literal 0, but you can't compare them to a 0 that is stored in an integer. If you try to do that, you're going to get a compiler error. The three-way comparison operator is meant to be used by the compiler to generate all the other comparison operators. For example, we can generate the greater than versions, we can generate the less than versions, we can even generate the equal operators if that's what we want. So a three-way comparison is going to return a type that is going to describe the kind of comparison we support for our type. For example, we may mean that our comparisons are going to support absolute equality using strong ordering. We can mean that our comparisons are going to support equivalence and not absolute equality using weak ordering. And we can mean that our comparison may support incomparable values using partial ordering, and that's really cool. Okay, so when we get to set up our own three-way comparison, we're going to see that it's going to be mostly set up as a member function, but there are special cases where you may use it as a non-member function, and we're going to have a chance to learn about that in a few lectures ahead. Okay, so now that we have really seen the information about the spaceship operator, let's head over to Visual Studio Code and run some code to really play with this a little more. So here we are in our working folder, the current project, is three-way comparison operator. We're going to grab our template files like we always do, and we're going to put them in place. And we are going to open this little guy in Visual Studio Code by dragging and dropping here. This is going to give us our main CPP file. We can clean it up a little bit. And we are going to try and play with the three-way comparison operator a little bit in code here. In our slides, we have said that it is really an operator whose result embodies information about a comparison. And it can give us information about the comparison in one go. So for example, we can know the greater than relationship, the equal relationship, and the less than relationship in one go. And here is a simple example that does that using just the string type. We're going to include that here. And the main message here is that three-way comparison is nothing new in C++. We have been doing this all along, but now we are porting the idea to a completely new operator that is built into the C++ language. So, for example, here, if we use the compare function, it is going to return a int. You can see the signature of the function here in Visual Studio Code, and the int is going to be positive if the first operand is greater than the second operand. If M1 is greater than M2, the result is going to be positive, so that's going to be greater than 0. If the return value is a 0, we're going to know that the first operand is equal to the second operand. So this is how we use three-way comparison. We're going to do a comparison here, and the result of the comparison is going to be stored in this variable called result. And we can use this result variable to know the greater than relationship, the equal relationship, or the less than relationship here. And if we try and run the program, that's going to work. We're going to build this with GCC. The build is going to be good. We can bring up a PowerShell window and run Rooster. And this is going to tell us M1 is less than M2 because this is going to be doing alphabetical comparison, and the world is going to come after hello. So world is going to be greater than hello. That's why we see the message here. Hello is less than world, and M1 is less than M2. This is the result we see here. This is nothing new. If we hop over to our search engine and put in strcmp, we're going to search this, and we're going to use the CPP reference link we get. We're going to click on that. And if we look at the result we get, this is going to be comparing two strings. And let's look at the return value. The return value is going to be a int, and it is going to be negative if the first operand is less than the second operand. It's going to be 0 if they are equal, and it's going to be positive if the first operand is greater than the second operand. Again, the result of this comparison is going to be stored in a variable, and we can use that to know if something is greater than something else. We can learn about the equal relationship or the less than relationship using the return value of this function here, and this is really cool. So this is really the same thing we can do with the three-way comparison operator. And I don't think I really said this in this lecture, but the three-way comparison is also informally called a spaceship operator because some people think it looks like a spaceship. If you want, you can call it a three-way comparison operator or the spaceship operator. It's really not going to matter. We're just learning about how it works here. I am going to put in a piece of code to play with us. So I am going to comment out the string code we had on top. I think you understand the purpose for this now. So we're going to put this out using a block comment, and we're going to set up two integers. We're going to compare them, and the result of that is going to be used to know if something is greater than the other. And another thing you should know that we have pointed out in the slides is that the result of the three-way comparison can only be compared with literal 0. You can't compare that to a 0 value that is stored in a variable. For example, if we try and store a 0 in an N3 and try to say is the result of N1 spaceship operator N2 greater than N3, we're going to get a compiler error because the return value of a three-way comparison operator can't be compared to a int. it can only be compared to a literal value of 0. This is really important. If you try to use a 0 value stored in an integer, you're going to get a compiler error, and that's really bad. You should avoid this. Okay, so now you know that you can compare n1 and n2 using a spaceship operator, and the result of that is going to be stored in a variable. And if you hover over this result variable, you're going to see that C++ is going to deduce that the type of this is std strong ordering. So this is going to mean that we can do absolute equality in our comparisons, because that's the default comparison that the int type does in C++. Okay, so now that we know about the spaceship operator, let's look at how we can use it to deduce our comparisons. Because the end goal we really have is to be able to compare and know the greater than relationship, the greater or equal relationship, the equal relationship, and we can really try and do that. So what we're going to do is try and see if n1 is greater than n2, and the way to do that, you say is n1 greater than n2 using the spaceship operator, and the return value, which is really going to be an std strong ordering type, the value in that, we're going to see if it's greater than 0. And if this gives true, we're going to know that n1 is going to be greater than n2, and we're going to see the true printed out here if that happens to be the case. Okay, so we can really use this to know if something is greater or equal than the other. We can do something like this, and this is going to give us the relationships that we want using the three-way comparison operator. I want to point out that this is not something you are going to do in user code. This is basically something the compiler does behind the scenes to use the spaceship operator to generate all the other operators for you. For example, the compiler can use the spaceship operator to generate a greater or equal operator. It can use this operator to generate the less than operator. It can really do all kinds of crazy things. I just want you to be aware of these comparisons here. If we try and build and run this program, we're going to use GCC to do that. The build is going to be good. We're going to clear and run Rooster. We're going to see that our comparisons are really working right. We know that we have a 5 and a 5 in here. So if we try and see that n1 is greater than n2, we're going to get a false because n1 is not greater than n2. We just have 5 in both of them. If we want to see if n1 is greater or equal to n2, that's going to be true because they are equal. So the equal here is going to win, and we're going to get a true. They are equal. We're going to get a true here. n1 is not less than n2. We're going to get a false. And n1 is less or equal to n2 because they are equal. So we're going to get a true here. You can see that we can deduce our relationships using the spaceship operator or the three-way comparison operator. And this is really cool. This is what the compiler is going to do to deduce these operators if you just set up a spaceship operator. But we're going to see the details of that in the few lectures ahead. For now that we know how this operator works, we're going to see a little more information about the return values or the return types we get from comparing things using the spaceship operator here. So let's comment this out. And we're going to learn about strong ordering here. So let's do strong ordering. And let's set up two variables. We're going to set up n1 or n4. We can use that. And we're going to put in a 5. And we're going to do n6 or n5. Yeah, we need to do n5 here. And we're going to put in a 9. Why not? And once we have this in place, we are going to try and do comparisons. We see here, we're going to try and see if n4 is greater than n5. We can also use the equal relationship. We're going to do that. And we can also do a less than relationship here. Let's make sure this is right. And we're going to do a less here. Let's delete and put in less. So the main message is that this is going to be using strong ordering behind the scenes. And what we mean by strong ordering is that we can have absolute equality. And if we say that we have a 5 in n4 and we have a 5 in n5 here, and we try and test and see if n4 is equal to n5, the values in these variables are going to be not distinguishable. You can't really tell one from the other, and they support absolute equality. This is really a defining feature of strong ordering in C++, And this is a good example of that. If we try and run this program, we're going to get a false because n4 is not greater than n5. We're going to get a true because n4 is going to be equal to n5. So we're going to get a true here. And this is really absolute equality. You can't tell the value you have in n4 from the value you have in n5. They are absolutely equal. And in this third statement here, we're going to have a false because the one in n4 is not less than the one we have in n5. And I don't think I really need to run this, but I will do that anyway because that's my habit. I like to run my programs just to see if I don't have any boo-boos in. And this is the result we expect. We can also put a std bool alpha in front. Let's do that so that we can get true and falses in our output. We're going to say std bool alpha. And this is going to give us good output here. We're going to build with GCC pretty quick. And the build is going to be good. We can clear and run our program. We're going to see that we get the results that we expect. We're going to comment this out and look at weak ordering. And we are going to set up two strings. I think we can go on top and actually grab two strings. And we're going to put these in here. One is going to say hello. Not in uppercase, it's going to do that in lowercase, but the other is going to say that in uppercase. This is what we used in the slides, and we're going to try and compare these things. We're going to do the same thing basically, so I am going to copy what we did on top and paste that down here. And we're going to be comparing M1 and M2. So let's say that here and M2. Okay, so we have our code in here to do our comparisons. We're going to take out the results here. And the main message is that it is possible to set up something like this and use equivalence rather than absolute equality. And equivalence is really a defining feature of weak ordering. It is possible to have two things to be equivalent, just like we have these two strings here having the same message. The message is hello. If you read this, you're going to know that it says hello, and in that regard, they are equivalent. But they are not absolutely equal, because if you look at them again, you're going to see that they are different. One is in all uppercase, and the other is not. One thing you should know is that by default, std string uses strong ordering in C++. So if you run this, you'd want to see the result of weak ordering, but we can do that. And we are going to see an example of how we can force std string to support weak ordering. And that's going to be really cool. Here, I just want you to grab the ideas. I am going to comment this out. Let's say that here, we're going to say partial ordering. And we are going to reuse the example we saw in the slides. One particular thing I need to point out is that to get access to nan or not a number, we will use this kind of syntax here. And to get access to this, we need to include the limits header because that's where the numeric limits thing lives. So we're going to come back to our code and include the limits header. Let's do that. And we are going to go down and put in our piece of code. Let's do that pretty quick. We're going to put in the code to set up two double variables. One is going to contain a valid piece of data in our double variable. The value is 33.9, but D2 contains none. And if we come here to C++.com, we're going to see that none values are used to identify undefined or non-representable values for floating point types. And good examples include trying to compute the square root of a negative number or trying to divide 0 by 0. These are going to result in none or not a number. And this is C++'s way to tell you that these things are really not representable in any computers in our time. So these things are not really comparable to any other floating point values. What we're going to do in our program here is set up a none value using this syntax, and then we're going to store that in our D2 variable. And what we're going to do is try and compare this not a number or this none to valid pieces of data, and we're going to be using this D1 variable here. So we're going to use the greater than operator, the equals operator, and the less than operator. And some of you are going to find this weird. All these are going to evaluate to false. Let's try to run and really drive this home. We're going to build with the GCC, and we're going to bring up a PowerShell window to try out our program. We're going to run Rooster, and we're going to see that D1 greater than D2, this is false. D1 equals to D2, this is false. And the D1 is less than D2, this is false. And this is C++'s way, again, to tell you that we can't really compare none to other double values that are valid. And if you try to do that, you're going to get falses like we do here, because the computer is telling you, I can't compare this thing to other things. So if you ask the computer, is D1 greater than D2? The computer is going to tell you, D1 is not greater than D2 because I can't compare to a none. If you try to do D1 equals to D2, again, the computer is going to tell you they're not equal. I can't really compare to a none value. And the same if you try to compare D1 to D2 using the less than operator, this is going to be false. And this is a defining feature of partial ordering. Partial ordering is a kind of comparison that supports incomparable values just like the none we looked at here. And if the type you are designing operators for happens to support these incomparable values, partial ordering is a good type to return from your spaceship operator. This is the main message I have to share here. And this is really all I had to share in this lecture, giving you a smooth introduction to the three-way comparison operator or the spaceship operator. I apologize, the video turned out to be really long, but there was a lot of information to cover, especially these kinds of types you can return from a spaceship operator. And this is going to become very critical when we get to implement our own spaceship operator, as we are going to see in the next few lectures. Again, to sum up, the three-way comparison operator is going to embody the results of a comparison, and it can be used in one go to deduce the other operators. You can deduce the greater than operator, the greater or equals operator, the less operator, and the less or equals operator. And we're going to see a way we can set up the equals operator, I think, starting in the next lecture. The spaceship operator is going to return a type whose value is comparable to literal 0. And we have three options of types we can return from a spaceship operator. We can return strong ordering, we can return weak ordering, or we can return partial ordering. We have seen that strong ordering hints to the fact that we support absolute equality. Weak ordering is going to hint to the fact that we can support equivalence and not absolute equality. And partial ordering is going to hint to the fact that your type may support incomparable values, just like we saw with double in a little while. Once we get to the point where we set up our own spaceship operators, you're going to see that in most cases, you're going to do that as the member function, but there are rare cases when you will need to do this as a freestanding non-member global function. This is really all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to see how you can set up a default equality operator for your types. Go ahead and finish up here and meet me there.